Imagine a vast, globally interconnected digital economy. Every single second, thousands of transactions, massive smart contract executions, and just huge waves of liquidity are flowing through a network that literally never sleeps, right? That is the promise of Web3. But behind the scenes of this incredible financial engine, there's actually a hidden, high-stakes war being fought over the very foundation it's all built upon. Welcome to this explainer. Today, we're popping the hood on the blockchain economy to see how it really works, and more importantly, how it might break.
So, what if the biggest threat to blockchain scaling isn't actually speed, but the way blockchains were designed from the very beginning? For years, the industry basically assumed a blockchain should execute transactions, secure the network, store data, and reach consensus all by itself. And hey, it worked, but only up to a point. Now, a growing number of engineers are arguing that the future of crypto depends on separating these functions into specialized layers. But if modular blockchains are the answer, why are some of the most successful networks still totally committed to the monolithic model? Behind this debate lies a huge battle over scalability, decentralization, security, and honestly, the future of crypto infrastructure.
Before we unravel this, please note, this explainer on the channel Blocks Bonds Funds is created for educational and informational purposes only and does not constitute financial or investment advice.
Okay, let's dive into this by rewinding just a bit to the baseline. At its absolute core, a blockchain really exists for one main purpose: trustless, decentralized coordination. Trustless, meaning you don't have to rely on a central bank or some middleman. Instead, you've got a distributed ledger of records, cryptographic security to make sure those records absolutely can't be forged, and a consensus mechanism so all the computers, the nodes, agree on what the actual truth is. That's the foundational recipe that Bitcoin established.
But to actually pull off that trustless coordination, every single blockchain is essentially performing four massive heavy lifting tasks. First up is execution, which is processing the transactions and updating account balances. Second is consensus, basically deciding the order of those transactions. Third is data availability, guaranteeing that the transaction data is published and verifiable by anyone. And finally, settlement, the ultimate layer of truth where disputes are resolved and transactions become permanent. Think of these as the four structural pillars of any chain.
And this brilliantly illustrates exactly what happens when you try to balance all four of those massive functions on a single network. It's the famous Blockchain Trilemma, a concept coined by Vitalik Buterin. It states that a blockchain can only really optimize for 2 out of 3 properties at the same time: scalability, security, and decentralization. If you want maximum security and decentralization, like Bitcoin or early Ethereum, well, your scalability is going to suffer. You can only process a handful of transactions per second, which means high wait times and frustrating bottlenecks for users.
Which brings us right to the root of the problem: the monolithic architecture. A monolithic blockchain tries to do everything: execution, consensus, data, and settlement, all on one single layer. But this design essentially locks scalability and decentralization into a zero-sum game. You know, when a monolithic chain tries to increase its block size to handle more transactions, the hardware requirements to run a node just skyrocket.
And that leads directly to a breaking point. If you scale horizontally within a single layer, you eventually price out the average user from running a node. When fewer people can afford the crazy expensive server infrastructure required to validate the network, the whole system centralizes, and the network security guarantees degrade. On the flip side, if you artificially keep node requirements low so anyone can run one, the network congests under heavy demand and transaction fees absolutely explode. It's like you're trapped.
Enter the modular paradigm shift. Instead of forcing one canonical layer to do every single thing, engineers are essentially bypassing the trilemma by unbundling the blockchain. They're separating execution, consensus, data availability, and settlement into highly specialized, independent layers. Think of it like moving from a single craftsman trying to build a car entirely from scratch to a highly optimized, specialized assembly line. It's a total game changer.
Let's look at a side-by-side comparison of these two ecosystems. On the monolithic side, blockchains like Solana embrace the all-in-one approach. They optimize a single layer for massive throughput, aiming for up to 65,000 transactions per second. It offers incredible simplicity for developers and a unified environment. But on the modular side, we see a completely different philosophy. Here, specialized layers snap together kind of like Lego bricks. You might have an execution layer on top, secured by a settlement layer below, and all of it anchored by a massive, dedicated data availability layer.
Let's move over to execution and see how this builds out in the real world, specifically with rollups. So, in the modular stack, execution is outsourced. Rollups process thousands of transactions off-chain, meaning they compute all that activity on a separate, much faster network, compress them all down, and then submit a tiny cryptographic proof back down to the layer 1, like Ethereum. They take the computational heavy lifting entirely off the main chain, which instantly multiplies the network's throughput while still inheriting that base layer's rock-solid security.
But not all rollups are created equal. We've got two main combatants here, optimistic rollups and ZK rollups. Optimistic rollups like Arbitrum or Optimism assume all transactions are valid by default. They rely on economic incentives and fraud proofs, where anyone can dispute a bad transaction during a basically 7-day window. ZK rollups, on the other hand, use zero-knowledge proofs. They don't rely on trust at all. They use advanced mathematical validity proofs that guarantee correctness instantly.
So the crucial point is this. Even with all that off-chain execution, we still haven't solved the whole puzzle. We arrive at the final boss of blockchain scaling, which is data availability. Whether you use fraud proofs or validity proofs, the underlying transaction data absolutely must be published somewhere reliable so anyone can reconstruct the state or challenge bad actors. But posting massive amounts of rollup data onto a busy layer 1, that is incredibly expensive.
This is where cryptography steps in with a really elegant solution, data availability sampling. It uses a technique called erasure coding. Think of it kind of like a hologram, where even a tiny little shard contains the blueprint for the whole image. It mathematically stretches the data block out. This allows a light node, literally even just a smartphone, to randomly sample tiny scattered chunks of the data. If those random spot checks succeed, the node has near certain cryptographic proof that the entire block is available to the network and it never even had to download the whole thing.
This breakthrough birthed entirely new networks, most notably Celestia. Celestia completely inverts the old model. It doesn't even have smart contracts. It deliberately ignores execution altogether. Its sole specialized purpose in life is just to provide consensus and data availability using that sampling technique we just talked about. By stripping away computation, it becomes this hyper-efficient data engine that rollups can just plug into for pennies on the dollar.
Even Ethereum itself is aggressively pivoting to this modular future. Just look at the EIP 4844 upgrade, also known as proto-dank sharding. Before this, rollups had to post their data as permanent, expensive CAL data on Ethereum. EIP 4844 introduced a totally new transaction type called blobs. Blobs are large, cheap data packets that are verified by the network, but then automatically deleted after about 18 days. It perfectly balances the need for temporary data availability without permanently bloating the blockchain storage.
But we have to be totally honest here. Modularity is not some magic wand. There are severe trade-offs. When you chop a blockchain into pieces, you break composability. If I have funds on one rollup and I want to interact with a smart contract on another, it's actually really complex and requires bridges. This fragments liquidity across different execution layers and introduces massive architectural complexity. A monolithic chain might congest, sure, but a modular chain can fail in highly creative, complex ways across multiple layers.
And that brings us to the core battle happening right now. We have two incredibly powerful visions racing toward the exact same goal of global scalability. The monolithic vision offers seamless composability, a unified user experience, and a beautifully simple developer environment. On the flip side, the modular vision offers theoretically infinite scaling, incredibly low fees, and flexible, specialized layers. Neither architecture is flawlessly perfect. It's entirely a choice of structural trade-offs.
So who actually wins? Well, the reality is that the future of crypto infrastructure probably isn't a zero-sum, winner-takes-all scenario. We are highly likely heading toward a hybrid, multi-layered global ecosystem. We'll have high-speed, synchronized monolithic chains handling high-frequency trading and consumer apps where instant composability is absolutely key. And right alongside them, massive modular stacks will handle heavy data loads, enterprise rollups, and complex financial settlements. And importantly for the everyday user, all this underlying complexity will eventually fade completely into the background, just like the invisible internet protocols we rely on today.
As these systems evolve, they will ultimately determine how trust, finance, and data flow globally for the next decade. Two competing visions are racing toward the same goal, but only one may shape the next generation of blockchains. The question is, which one is right, and what happens if the industry chooses the wrong architecture?